So when we're solving problems in dynamics, we're going to take a very similar approach as we have done so far for statics. So we're going to make our idealizations. We're going to draw the coordinate system. We're going to free the body from the surroundings and draw our free body diagram. But because our objects are in motion, either translational or translational and rotational motion, we have to draw a kinetic diagram or kinetic body diagram. So FBD, KBD, and that will simply be, for example, if I have basically, let's say a tire wheel that's spinning like this, and that's also translating with some acceleration like this, we're just going to draw something that's simple like that. So we're not going to draw the forces, we're just going to look at the acceleration. So if we're accelerating in this direction, mass times acceleration in the x, plus we have some angular acceleration alpha here, we have our IG here. So this would be essentially our kinetic body diagram. Then we're going to write out our equilibrium expressions. Remember some of the forces in x equals ma x, some of the forces in y equals mass acceleration. And I'm going to say linear acceleration. So acceleration y, and then finally some of the moments around free body equals IG alpha, or just around any particular point P here, for example. So if we were to do that, so the sum of the moments are about P, basically if there's a force here, and actually I don't want to give away the ending, but we'll tackle that once we look at problems. So again, we can have problems that have translation and basically angular acceleration, or we can just have angular acceleration, or we can just have linear. Again, we can break down and start to solve problems and use our formalism. So that's the theory. Now let's start to solve for a fun problem. So a truck that's carrying a table as a load. So we'll see you in the next video. Thanks. Bye.